Alright, let's look at the practice exam 1, problem number 4. Alright, so we want to use the shell method to find the volume of the solid obtained by rotating a region bounded by y equals x minus x squared, which is a facing down parabola, and y equals 0, which is the x-axis, and about the vertical line, x equals -1. Alright, so let's sketch the region first. So it's going to look like this. So you have x-axis, alright, and here is the y-axis, maybe somewhere around here. Alright, and so this parabola, if you factor it out, you see the x-intercept. So y is equal to, alright, factor x out. So then you have 1 minus x, right? So it looks like 0 and 1 is the x-intercept. So here's 1, here's 0, and because of the negative leading coefficient, we know that it's a facing down parabola. So it's going to look somewhat like this. All right. And then x-axis, so we are talking about this region right here. Alright, then we rotate this region about the vertical line, x equals -1. So right here, it's a -1. And here's the vertical line here. Alright. Then you're going to rotate, so this is x equals 1, -1. Then we rotate it about this vertical line here, like that. Alright, so we're talking about the shell method. So let's sketch the part of the shell so that we have some idea. So I'm going to take some random x value here, right? And this is going to be the height of the shell, right? Then we're going to rotate it about the this vertical line. So it's going to look somewhat like this. Right? Oops. Alright, so let's see if I can draw this a little bit better. So it's going to look kind of like this. And here, it's going to look like that. And it's going to look like that. I'm going to just draw a part of the shell. Then here, this side, I guess you can't see those. So it's going to look like that. Alright, so let's set up the integral here. Alright, so volume using the shell method. Alright, the shell method, you're going to have 2 pi in front. And the integral. And the region starts from 0 to 1, so here's 0 to 1. Right, so what we need here is radius. Right, so we need the radius. Alright, so radius is going to be, so this is x, but it's the axis of rotation is at -1. So it's the distance between x and -1, so x minus -1, so it's going to be x plus 1, right? It's a double negative. Alright, then we want to find the height of the cylindrical shell. So this is going to be a height. And height is determined by this parabola. So we know that it's just going to be x minus x squared. Alright, then width of the cylindrical shell is going to be delta x. So I'm going to put the dx. Alright, so that's that. Alright, so let's evaluate it. So this is going to be 2 pi and an integral from 0 to 1. Alright, I'm going to just multiply out. So distribute, say, x2, x, and also -x squared. We get x squared minus x cubed. Right? Then we distribute 1 to x and the -x squared. So it's going to be plus x minus x squared. And this is with respect to x. Alright, so we can cancel x squared here and a minus x squared. Alright, then we can just use power rule to find the antiderivative. So you have a 2 pi. Alright, antiderivative of negative x cubed would be negative x to the add 1 to the power and divide by that power. Alright, and plus add 1 to the power, so x squared, and divide by 2. Alright, then you're going from 0 to 1. Alright, so this is going to be 2 pi. Alright, we plug in 1, so it's going to be negative 1/4, and plus 1/2. And minus, plugging 0, it's all 0, so I'm not going to write anything down. So it's going to be 1/4 times 2 pi. So this is going to be pi over 2. Right? So this is the volume of the solid of rotation using shell method. Right? That's it. I hope that this was clear.